to environmental hazards. Okay? And is adaptive specific? Yeah, it's specific against a particular pathogen. Once it's inside my body, adaptive takes over, and it's like, okay, let's just try to kill this. Now, we've already done this, B cells, T cells, and K cells. I'm not going to talk about that again. Sites 1 through tissues. Okay, we talked about bone marrow and whatnot. Okay, we've talked about this, NK cells, T cells, all that. Now, are antibodies made of proteins, or are they cells? Proteins. Antibodies are made of what? Proteins. Which is bigger, a protein or a cell? Cell. So which one's larger? Just look at it here. Look at the size of that cell compared to that really tiny protein. Which is bigger, the cell or the protein? Cell is always bigger than protein, guys. Always, 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 always. Okay? Now, what cell, I'll give you some choices, which cell is able to directly attack and kill a abnormal cell? Is it 1, a B cell, or 1, a B cell, 2, is it a cytotoxic T cell? Which one, again, is directly able to attack? Is it a T helper cell, which is number 3? Is it an antibody? I'll put IG for number 4. Okay. Or is it a plasma cell? That's number 5. Plasma cell. Which one is able to directly attack it? Well, B cells just become what type of cell? Plasma cells. And so plasma cell can't be it, B cell can't be it. What do plasma cells secrete? Antibodies. So number 4 can't be it. So you have number 2 and number 3. Your cytotoxic T cells and T helper cells. When you think of T helper, they're not really picking the fight. Okay, so T helper cell is kind of like the one who tells you who deserves to get removed. The cytotoxic T cell is the one that actually does it. So which cell is able to directly kill? And notice I use the word what? Cell. What cell is directly able to kill? And the answer is what? Cytotoxic T cell. Is an antibody a cell? No. So the answer can't be antibody. Okay. Is innate specific or non-specific? Non-specific. Is innate specific or non-specific? Non-specific. Okay, so make sure you memorize this, guys. Make sure you memorize this list right here. Okay? These are all part of innate or non-specific defenses. So is the skin part of innate or adaptive? Innate. Is it part of innate or adaptive? Innate. Phagocytes, such as macrophages, again, monocyte is in the blood, macrophages is when it leaves the blood. Eosinophils, neutrophils are part of what? Innate or adaptive? Innate. Guys, a lot of people get this, used to, not anymore, since I've been trying to stress this, okay? When you think innate, don't just think white blood cells, okay? Because macrophages, eosinophils, neutrophils are all white blood cells, but they're part of innate, okay? NK cells, okay, are part of that as well. Don't worry about immune surveillance, okay? NK cells are part of innate or adaptive? Innate. What about interferons? Innate. What about complement? Innate. What about inflammation? Innate. What about fever? Innate. Okay, so let's go back over a couple things to make sure. I want to go over these right here, okay? Interferons. Okay, so do interferons interfere with viral replication? Yes. What do interferons do? Interfere with viral replication. What do interferons do? Interfere with viral replication. What interferes with viral replication? Interferons. Complement. Is complement a protein? Yes. Is it a protein produced by the liver? Yes. Is complement a protein? Yes. Is complement a series of 20 proteins? Yes. I'm not going to ask you the specific number, but I know myself, I usually like to say a series of proteins or a bunch of proteins. I probably won't use the word bunch, though. Probably a series of proteins or a collection of proteins. Now, are these proteins found in the blood? Yes. What organ produces complement? Liver. What organ produces complement? Liver. What organ produces complement? Liver. What is complement? A protein or a protein? Protein. Do these proteins fight infections? Yes. So name for me a protein that's found in the blood that's produced by the liver that helps fight infections. Complement. Name a protein that is produced by the liver that fights infections. Protein. What is the name of a protein that interferes with viral replication? Interferons. What is the name of the protein that interferes with viral replication? Interferons. Name for me a chemical that is responsible for blocking viral replication. Interferons. All I did was change the words, guys. It's the same thing. Interfere, block. Same thing. Interfere or block is the same thing. Is inflammation part of innate or adaptive immunity? Innate. Is inflammation part of innate or adaptive? Innate. Is short-term inflammation a good thing or a bad thing? Good thing. Does it limit the spread of the organism? Yes. Is fever part of innate or adaptive? Innate. Does fever help our blood cells work faster? Yes. Does it increase the metabolic rate of our cells? Yes. Does it decrease the metabolic rate of bacterial cells? Yes. So is fever in a short term good thing? Yes. Now, we have phagocytes. Okay, how do you remember the phagocytes? Macrophage, eosinophil, and neutrophil, men. It's macrophages. Where do they originally come from? Monocytes. Monocytes become what? Macrophages. What do monocytes become? Macrophages. What do monocytes become? Macrophages. What is the name, just to review, what is the name of a series of proteins produced by the liver that fight infections? Complement. What do we call a localized limit of a spread of infection? Inflammation. What do we call a rise in body temperature? Fever. Name the phagocytes. Macrophages, eosinophils, and neutrophils. Okay? Are they part of what we call the reticuloendothelial system? Yes. Are they part of the reticuloendothelial system? Yes. Are both eosinophils and neutrophils called microphages? Yes. So we have one macrophage and two microphages. Okay? Do eosinophils, and we talked about this already, so I'm going to review it from a previous video. Are eosinophils used to fight parasitic infections? Yes. Do eosinophils fight parasitic infections? Yes. Which one fights parasitic infections? Eosinophils. Is it also? Yes. Get ready to say yes. Do eosinophils also become elevated during an allergic reaction? Yes. What is the first white blood cell to arrive at the site of an infection? Neutrophil. Which is the first to arrive? Neutrophil. What's the most abundant white blood cell? Is it a neutrophil or a basophil? Neutrophil. Which is the least abundant white blood cell? Neutrophil. Basophil. Which is the least abundant? Basophil. Okay. Are macrophages a type of phagocyte? Yes. So do they engulf pathogens? In other words, do they take them in? Yes. Okay. Do they release toxins? Yes. Now we have two types of macrophages. We have fixed and free. Which one stays where it's supposed to in a tissue? Fixed. Which one's able to move around? Free macrophages. Which one's able to move around? Free macrophages. Which one stays fixed? Fixed macrophages. Is there anything called a fixed neutrophil? No. Is there anything called a free neutrophil? No. Is there anything called a fixed eosinophil or free eosinophil? No. The only one that we use the term fixed and free for are macrophages. That's it, guys. So there's only a fixed macrophage and free macrophage. There's nothing else that describes that. Now, how do phagocytes get ready for the enemy? Now remember, we talked about this in a previous video. Here's the blood. Here's the red blood cell. When it goes to the edge, what do we call that? That's called margination. So that's one. When it leaves and goes through the endothelial lining, which again is simple squamous epithelia, once it goes through, we call that diapedesis. So that's step 2. Diapedesis. Next, if the microbe's over here, okay, it's going to be attracted to the chemicals coming from that and coming from a mast cell. Remember the mast cell was over here? So here's the mast cell. Is the mast cell releasing histamine and heparin? Yes. Does histamine cause vasodilation? Yes. So does that make it easier for diapedesis to occur? Yes. What attracts? Is it positive chemotaxis or negative chemotaxis that attracts this white blood cell to the site of infection? Positive chemotaxis. So that's step 3. Okay? That's step 3. So remember, MDC, Medical Dr. Costa. Again, I'm not a doctor, but it just hopefully helps you remember that. Medical Dr. Costa. Okay? Next. What are the stages of phagocytosis? Guys, this is just memorization. FAIDE. F-A-I-D-E. First, it has to find it. That's really what this is. Okay? This is really the F. Okay? Of find. That's really what that is. Adhere means that this cell has to do what? Attach. Then, well, I made the bacteria huge, so this other cell should be much larger. Okay? Is it going to adhere to this bacterial cell here? Yes. Is it then going to ingest it? Yes. Is it then going to digest it and break it up? Yes. Is it then going to excrete it? Yes. It's going to be excretion. Okay? Is a little piece, if it's a macrophage, is a little piece of it, well, excuse me, not just macrophage, if it's any type of cell, is it going to leave a little piece of the bacteria on the surface? Yes. When it does that, it's now called what type of cell? An antigen-presenting cell. Okay? So I'm going to redo this just because I think I can do a better job than that. Okay, so it's going to go through, remember, we're going to go from here, from margination to, that's margination. Then the next step is, I'm going to make this large, diapedesis, and then the cell is going to be attracted by the chemicals of the mast cells, and it's going to go over here, and by the waste products of the bacteria, and it's going to do what? It's going to eat this cell. Okay, it's going to eat the bacteria. So how does it do it? First it has to find it, then it's got to attach to it, to the bacteria, then it's going to take it in. So now the bacteria is inside. Our lysosome is going to help break up the bacteria. Yes. So is our cell going to spit out, excrete some of the bacteria that's in red? Yes. Is it also going to present a piece of it on the surface? Yes. When one of our cells presents it on the surface, is the cell now called an antigen-presenting cell? Yes. Okay. We'll talk about that in a little bit. Okay, do NK cells kill cancer cells and viral infected cells? Yes. So what cell is responsible for killing viral infected cells and cancer cells? Natural killer cells. What does NK stand for? Natural killer. Okay. What chemical do natural killer cells release? Perforin. What is the name of the chemical that NK cells release? Perforin. Does perforin poke holes in our cells and viral infected cells and bacterial cells? Yes. Okay. Can NK cells kill our abnormal cells? Yes. Can they kill abnormal cells? Yes. Can they kill bacterial cells? Yes. Can they kill our cells that have a virus in it? Yes. Is another way of saying our cells that have a virus in it the same thing as saying viral infected cells? Yes, that means the same thing. So pause it if you need to, if you didn't write that down, just so that if you see something like this on the test, you're aware of it. Okay, so do NK cells kill cancer cells? Yes. Do they kill our viral infected cells? Yes. Do they also kill abnormally shaped cells? Yes. And I'm now going to record another video after this. This is the end of this particular video.